Alright, welcome to the first GatorTech workshop. Today we are going to be covering an introduction to Python. Originally this was going to be recorded live, but the workshop ended up having a lot of discussion that didn't get picked up by the microphone, so I thought I'd just go ahead and record this after the fact. So first let's go ahead and grab all the files we need. Everything we need is going to be linked into the description. So starting with GitHub, the first thing you want to do is come to this green button that says Clone or Download and click Download Zip. Once that's done, you can go ahead and open it. Mac automatically extracts, I believe, but on Windows you're going to have to extract these manually. Now once that is all done, assuming you've installed Anaconda, if you're on Windows you're going to want to come to the Anaconda prompt by searching for that in the Windows menu, and if you're on a Mac you're going to want to go ahead and pull up what's that called, the terminal. Once you've done that, you want to type in the command cd, that means change directory. We want to go to our downloads folder, that's most likely where the Python workshop is saved. We'll go ahead and go into that, and then we can cd into Python workshops-master. And then again, if you're on Windows, you do need to do it one more time. And if you're wondering how I got it to automatically type in, if you type in part of the words, you can just hit the tab key on both Mac and Windows, and this will go ahead and autocomplete everything. Once they're in this folder, you're going to want to type in the words Jupyter Notebook. That's Jupyter with a Y. You press enter. Assuming you're in Anaconda, this will take a few seconds, and then eventually it'll go ahead, open up in your web browser with a screen just like this. Alright, and once you're at this Jupyter Notebook menu, you want to go ahead and click on the Intro to Python, the one without the solutions inside of the parentheses. Alright, so Python is an object-oriented programming language. What that actually means is not too important right now, but essentially Python's a very simple and powerful language. It's used in data science, other scientific fields, web development, some desktop and even mobile development. It's a little unique in the fact that, unlike a lot of programming languages you might be familiar with, it doesn't use curly braces or semicolon. It uses white space to change how the code blocks appear. So it's a little unique in how you write it, in a sense as almost like writing an English sentence rather than actually writing in a programming language. Alright, so Jupyter Notebooks, that's what you see in front of you, and Jupyter Notebooks are made up of cells which are annotated by these blue lines and sometimes green lines on the sides. And essentially what's important to know is these two hotkeys is, first of all, enter will let you begin to edit a cell like so, and if you press shift enter, it'll go ahead and run it and move on to the next cell. Alright, so getting started, the first thing we're going to do is hello world. That's like the introduction to every programming language ever. So first I'm going to type in the word print, open parentheses, and IPython, or Jupyter what it's called now, will automatically input closing parentheses and anything that needs to close out the statement. Then we're going to do double quotes and then type in hello, comma world. And then to run that, we're going to press shift enter, and at the bottom we're going to see the output of what we just typed in. So print is an example of like what's called a function, and then the hello world part that we put right in the middle is an example of an argument. The argument outputs or changes the output of the function. You can think of it like something in math where you have like 3x equals something. The x would be the argument, and the 3 would kind of be what happens every single time it runs. So if we want to change that, we could again type in print, and then we're going to type in something like by, and when we run that, it's going to output by. We can also output numbers. These don't need quotations, and we're going to explain that in another section, but the basic thing is anything you want to output to the screen you can use with a print statement. Alright, so comments allow you to annotate your code without affecting how it runs. This is important when you're writing large programs and you want to remember why or how you did something. So first of all, if you use the number sign, the hashtag, whatever you want to call it, if you use that, you can do what's called a single line comment. That way you can just comment out one little line. And if you want to do a multi-line comment, you use the 3 single quotes. So this is a multi-line comment. And then underneath all this, we can go ahead and we can put in another print statement. Say this is not a comment. When we run this, the only part that gets outputted is the print statement. So these comments are very useful for when you want to explain why you did something. That way anyone who's new to your code, or you're going back a few months later, you know exactly why something was done. And this little section right here, when should you comment? You should use them sparingly. You want to comment about why you did something rather than how you did something. Alright, so next up, variables. These again are like math. These are things that we can kind of assign to a value. And the notation is name equals value. So let's call the variable a. Notice we don't use quotations here because we want to make this a reference, something we can call back later. So we can say a equals, and we can assign to the number 1. Then underneath that, we can just say b equals 1 as the word. Press Shift Enter. That'll go ahead and save those variables. Nothing gets output, they just get saved. And then if we want to recall these at a later time, again, we can use print, open parentheses, and without using quotes, we can just type in the letter A. Underneath that, we can do the same thing with the letter B. And when we run that, it'll print out the values assigned with those two variables. Alright, so next up is data types. You've already seen a few of these like strings and numbers, so let's go ahead and do a string. Let's assign a variable A equals this is a string. And strings are just characters and numbers surrounded by double or single quotes. Python doesn't actually care which one, so we'll just use double in this case. And print that out. Print out this is a string just like we would expect. We can also get the type of a variable by using the word type, and then parentheses and the variable name. And that outputs string, str, which means string. We can also add strings together. It's called concatenating strings. So let's make a variable b equals, let's just give it a period, say this is an added string. And underneath that we can type in a plus b, run that, and then it'll go ahead and it'll automatically add on the second variable to the first. Next up, integers. Integers you've already seen. It's called c equal to 3. And integers are just numbers without a decimal. They're whole numbers. So we can say c equals 3. Then we can do type of c. And obviously that's going to be int. And for integer, if we made a new variable d and gave that 4.2, and we got the type of that, we would get a float. Floats are anything that have a decimal point past a whole number. One thing that makes Python a little different is you do not have to explicitly state the type of the variable. In languages like Java and C++, you'd have to explicitly state that's a string or that's an integer or something like that. One thing though is that while Python doesn't require you to state it, it does not automatically convert. So if we try to print out a plus c, where a is a string and c is an integer, it will give us an error saying it can't convert int object to string implicitly. And what this means is Python, it doesn't know if it should convert the integer to a string or the string to an integer, so it doesn't try, it rather just gives an error. So what we can do is we can use the string function in this case. So we can type print a plus, and rather than just typing in string, we can do or just typing in c, we can do str parentheses c. When we run that, it'll automatically convert the variable c to a string and print it on just like it should. There's other data types like instant floats, you can add them together. So we could do print, we could do c plus d. We get 7.2 just like we should. Of course, we can do math with those, so we could do variable e equals c to the power of d, and print that out. And we get a float in return because we gave it a float as one of the variables. One of the final and more important data types is called a boolean. Booleans always evaluate to either true or false, and that's very useful in flow control, which we'll cover a little bit later. And the point of this is if a user gives like a password and you want to make sure it's their actual password, you can do that with a boolean. So let's go ahead and let's do one little test, like 1 equals 1. And you'll notice I use 2 equal signs. This is the comparison operator, which we'll talk about later, of course. When we run that, we get the output of true, just like we should, because 1 is equal to 1. If we tried something like 2 is less than 1, it would output false. Alright, so next up is data structures, and these are just ways to store multiple pieces of data in a very efficient way. So the first step is lists, and these use square brackets to define it. So let's go ahead and let's call mylist equals, and then in square brackets we can give it a few values. Let's give it some strings, so we'll do this. In the quotations we'll put a comma to denote a new value. So this is comma a list. We can print that out, and this will just kind of show the values inside of it. You'll notice it might have single quotes here. That's fine. Python does not have there's no difference between single and double quotes in Python as long as they match. Another thing we can do is we can select an individual value from the list. It's important to note that Python is a zero index language, meaning that Python starts counting at 0. So in this list, the first one, this, is actually 0. So if you wanted to print that, we would do print mylist, and then inside of square braces, we would type in the number of the index we want to print. In this case, 0. And then we will have this printed out. If we change that 0 to say 2, we'll get A, and anything like that. You can also add values to the list. So using the insert function. So we can say mylist.insert. And then let's say we want to put something at the very end, which would be index 4. And the value, let's do a period. Then underneath this, we can print mylist. Run that. It'll automatically add in a 5th value in the 4th index, which is just a period. And let's say we want to remove a value. We can do mylist.remove. Let's get rid of, say, A. And give it A. Underneath that, print it out again. We run that, it'll say this is, missed the A value that we just deleted. So next up are dictionaries, and dictionaries are key value stores. These contain a key, which is kind of the name that you look something up by, and the values, which is what you want to store inside that. You can think of it like an address book where the name might be the key, and then the phone number would be the value. So we declare these using curly braces. So let's say my dictionary equals, and then curly braces. And the first thing we need to give it is a key, so we'll just call this first. And then you want to use a colon, and then again in quotes, we're going to say the first value. And then to start a new value, new key, we can do a comma again, then we can type in second as the name, colon, this is the second value. We can again print that out, my dictionary. And run that, it'll print it again with a single quote rather than double, but that's okay. If we wanted to print something out specifically, we would do print my dictionary. And then again, in square braces like a list, we could go ahead and type in the name of the key. So let's say we want to print out the second key, or the key called second. We can do print my dictionary second, and it'll print out the value of the second key. It's important to note you should be looking things up by the key. There's no good way to do search by value in Python, so you should always try to design your program to use keys rather than looking for values. Alright, you can delete something, so say del, which is the keyword you use for this, my dictionary, and then you have to give it the name of the key. So we'll give it first, and then we will print my dictionary again. And after we run that, it'll go ahead and it'll delete the first key and just leave the second one. So next up is flow control, and flow control allows you to control the logic of your program, and it uses those comparison operators we talked about earlier. And these are like the major comparison operators. You notice double equals just means is equal to, and then you can use an exclamation point equals to say not equals. Of course, less than, greater than, and then the equal to that goes along with that. And each of these returns a Boolean value, so either true or false. So we can use what's called an if-else statement. And these are like very basic logic we can introduce into our programs. These allow you to alter the output of a program depending on what goes in. So let's go ahead, let's define two variables, a equals 3, and then b equals 2. And then underneath that we can do say if a is greater than b, colon. Notice once you press enter, it'll go ahead and automatically indent underneath that block. That's to signify that anything underneath this if statement that's indented like that is part of that if statement. So let's do print a is greater than b. Come to the end of that, press enter. And now we're going to write our else part, so we can backspace out of that tab, type in the word else, colon. Again, it does the automatic indentation. And print b is greater than a. In this case, since a is greater than b, it's going to go ahead and it's going to say print a is greater than b once we run it, just like that. We can also use the else if. So we can say a equals 3, b equals 3. We can say if a is greater than b, we want to print out again a is greater than b. Underneath that we can use the else if keyword, which is elif. And then again we can define a condition. So let's say if b is less than, or if b is greater than a, then we want to print out b is greater than a. And then underneath all that, we can again come back to else, and we can say print a is equal to b. So once we run this, since both of the variables are equal to 3, it'll go through all of these and come to the else loop where it sees that a is equal to b and print out a is equal to b. So next up are for loops, and for loops allow you to iterate over an object like a list that we had earlier. So let's go ahead, let's do a new list, call it for_list. say equals, again, square braces, and let's just give it some numbers. 1, 2, 3. Let's give it 3 4s, and then 5, 6. Again, press Shift Enter to go ahead and save that list. And then to go ahead and iterate through that, we're going to type in the word for, and we're going to say item. The word that you put after the for, it's whatever you want to call it. Basically becomes a variable name. Let's do for item and for list, colon. Again, it automatically indents so we know what's part of the for loop and what isn't. And let's type in print item. When we run that, it's going to go through a list, and for every item inside that list, so like 1, 2, 3, 4, it's going to go ahead and print those out underneath. And again, you could put any function or anything like that under here, and it will go through every item and apply that function to it. We can also add some logic to that, so we can say for item in for list, just like we did. We're going to say if item is equal to, let's say for, that we want to print the item. When we run that, it's going to go through every object in the list, but it's only going to print it if that object is equal to 4. Then next up, all while loops. While loop allows you to just continue to perform an action as long as an expression is true. So let's declare a variable I. Say I is equal to 0. Underneath that, we'll type in while I is less than 5. We can go ahead and we can print I. And then underneath that, we can type in I plus equals 1, and then I'll explain this. So for while I is less than 5, we're going to go ahead and print out whatever I is equal to, starting at 0 up until 4. And then after we print it, we're going to increment the variable I by 1. Plus equals is a shorthand way of saying I equals I plus 1. So it's going to keep adding the value of 1 until eventually, when I gets to 5, it's not going to run this loop because it'll be greater than 5, or be more than less than 5. So now we get 0 through 4 just like we should. And again, we could say I is less than 10, and I'll print up through 9. Now, functions are another very important concept in programming, and these are kind of like the building blocks or the foundation of your website. These are called methods in languages like Java, but they're essentially the same thing. So in Python, to define a function, we type in def, and then the name of the function, so let's call it my function. And then we'll do open and close parentheses. We'll talk about what goes in those parentheses in a second. And like most other things in Python, we do a colon and have the indentation underneath to make sure we know what's part of what. So for this, let's just say print this is a function. Press Shift Enter to go ahead and save that function. And then we can come to the next cell and we can type in my function, then parentheses, and we run that. Spelled that wrong. So now we'll go ahead and run, and we'll see this is a function, just like we'd expect from this print statement. And again, to talk about what goes into parentheses, they're called arguments. So essentially, arguments change the output based on what you give it. So let's type in again, define my function, and then here let's put an argument, and we can name these whatever we want. So let's call it text colon, and then we'll do print text. So whatever we type in for this argument will go ahead and get printed out. So I'll run that cell, and then we'll type in my function. This is an argument. When we run that, it'll print out this is an argument. If we add anything to it, it'll just keep printing it out. You can have multiple arguments, of course. You could have, say, text. We'll do more text. So we'll add that, again, concatenate on the more text part. So we can say this is an argument, then do this is a second argument. Actually, let me rerun that. And then again, it'll go ahead and it'll concatenate the second part of the string. Another important thing about functions is what's called the return keyword. So normally you wouldn't want to just say print something out at the end of the function. You want to give it back a value. So again, let's define my function. We won't give an argument this time. Let's go ahead and we'll say return. This is a return value. So if we go ahead and we type out my function and we run that, we'll see output in the single quote says this is a return value. So basically what would happen is if you had another function or value that depended on the function we just wrote, it would rather than having to print it out, it could just go ahead and get the value from that. So if you had a function that took two numbers and added them together, you'd want to return the value rather than just print it out. And the last part of this workshop is importing modules. This is so you can write code in one file and reuse it in another. Also, a lot of stuff inside of Python you can't just use it right away, you need to import it first. So like let's import the random library, which allows you to generate random numbers. So to do that, we'll type in import random, run that cell. There's no output, but we do now have access to the random number generator. So let's type in print, and we'll do random.randint, R-A-N-T, and then we'll give it a range, say 0 to 100, and we run that, it will output 53, and every time we run this, we will get a new number. You can also use what's called import from. So if we only wanted one specific piece of the random library and we didn't want it to say random dot, say randint every single time, we could do from random import randint, run that, and now rather than having to type in random dot randint, we can just type in randint and go ahead and give it a range again. It'll do the exact same thing and continue to work. Alright, so that wraps up the first workshop. This is just some additional reading under here. Example of like who uses Python. Dropbox does, Google does, Reddit, Instagram, and Instagram is one of the largest production sites actually using Python. Additionally, here's some next steps. Codecademy, it's a good way to learn syntax of different languages. There is Learn Python the Hard Way and Automate the Boring Stuff, which are both kind of like laid out like books. And there's also the Coursera Python specialization if you want a more structured course. And then of course there is the subreddit for Learn Python where you can ask questions and get help on various issues. So that's the end of the workshop. If you have any questions, you can reach me on Slack. It's just @Ryan, or you can leave a comment on the YouTube video. And thank you very much for watching.